Hello, this is Corbin, and we're back at you again with another CCSP study guide, Chapter 7. This will be going over cloud application security. So first, let's talk about training and awareness. So we need to determine data sensitivity. That will be involving PII, PHI, intellectual property, IP. So PII is, of course, personally identifiable information. PHI is personal health information, and IP is intellectual property. These are all important things to identify and determine as sensitive. Then we need to consider our responsibilities within the cloud model. So that, of course, depends if you're IaaS, PaaS, or SaaS. You'll have shared responsibilities that'll differ. I've went over those prior to this video. You'll have cloud provider responsibilities that differ between models, and you'll have cloud customer responsibilities that will also differ between models. So considering those responsibilities is an important portion of developing a training and awareness model. So forklifting, what is forklifting? This is migrating the application with no code changes. Not all applications are natively ready to be forklifted into the cloud. Training developers for the cloud. So first they have to be trained on risk, threats, and vulnerabilities. These should be modeled after the Cloud Security Alliance Treacherous 12. That's a great resource for the biggest 12 risks, threats, and vulnerabilities to the cloud, and then there are the egregious 11. You must also train the developers on cloud migration, how that process works, so that they can prepare everything to migrate and ensure that code is developed properly and pushed properly to the cloud. And then, of course, the learning curve for developing in the cloud as opposed to on-premises. Of course, they may have already started by using virtualization technology, but of course, they're going to have to use virtualization a lot in the cloud to develop. Like I said, they may have done this before to sandbox, stuff like that, but there is a learning curve definitely for the cloud. So some issues to train on, that would be multi-tenancy. Let them know that their environment is probably going to be multi-tenant. There's going to be other people within the same cloud hardware, and we don't want our information to bleed over or their information to bleed over to ours. Third-party admins, because the admins of cloud data centers will be, they will have their own admins for a lot of things. They need to know the deployment models and what deployment model they're using. If we're using a public cloud, we need to tell them, and we need to tell them what that entails: private cloud, community cloud, or hybrid cloud. We went over those in other videos, and we'll go over them several more times, so I won't explain them each in depth. And the service model that you're using so that we can determine responsibilities: IaaS, infrastructure as a service, platform as a service, and software as a service. And then what encryption technologies can we use in the cloud as opposed to on-premises, or what shared encryption technologies can we use? So some common cloud deployment pitfalls. There is on-premises versus off-premises functionality. They're two different things. Poor documentation and training. Everything needs to be documented properly during the development process. With poor documentation, there will be a lot of issues in fixing problems and or identifying problems properly. Tenancy separation. We talked about that just prior. Use of secure and validated APIs. All APIs need to be secured and validated properly. Otherwise, you can have a lot of issues with on-path attacks and or information bleed. On-premises versus off-premises. So, designed for legacy environments, there are numerous calls as opposed to one call within the API. And they're slow and take resources if not optimized for cloud and multi-tenant environments. So these are the difference between an off-premise. An off-premise would be designed for legacy environments. That's fine. Numerous calls as opposed to one call, and slow and take resources if not optimized for cloud and multi-tenant environments. So poor documentation, this is a concern. And this is something that you need to know for the exam, as it will be on there. Documentation is seen as an inconvenience to many personnel. This is one reason for poor documentation. It could be conducted by a non-expert, which is a lot of the time. I mean, you're not going to have a documentation expert on hand all of the time. It may just be a normal developer who hasn't done it before. So, and then the developers need documentation during migration. That's one of the most integral parts of this portion, is that documentation is going to be super useful and integral during cloud migration. Not all applications are cloud ready. So prior to migrating to the cloud, the application, the developers should reevaluate the code, ensure that it meets the requirements to move over to the cloud. They're going to have to evaluate it and see if there's new encryption is required in the cloud environment as opposed to encryption that we've used in the legacy environment. And then what configuration changes are we going to need to ensure that not only we are secure and we are able to migrate to the cloud easily. Tenancy separation, as we've talked about prior, tenancy separation is just separating from other tenants within the cloud environment. This is trying to avoid data bleed. And then here are some countermeasures for tenancy separation to ensure that data bleed does not occur and that other tenants don't get access to your data. Access control is always an important one. Process isolation, isolating the processes. Denial of guest/host escape attempts for virtualized instances. There are some viruses that can conduct guest or host escape attempts, and you can also try it within the virtualized instance as well. So denying those is important to securing in a multi-tenant environment. And then lastly, of course, is secure remote administration, as the cloud is a distributed place and you are going to be doing most of your stuff through remote administration. So as far as APIs go, some considerations that are important would be to formalize the policy and process for vetting the API, ensure that the API is solid when you vet it prior to using it, selecting the APIs, and then deploying the APIs. All of those three things need to be considered during the process, and it should be in a formal policy. The cloud secure development lifecycle starts with defining, designing, development, testing, secure operations, and disposal. We're going to go over each one of those in depth here shortly. So the defining phase is mostly concerned with identifying business requirements, whether they're accounting, CRM, customer management, or databases. What business requirements do we need to facilitate with this software? Designing, so developing user stories. This is basically saying how a user is going to access. You're going to make a story of how the user is going to interact with the application and what they should expect. And this will give you an idea of what your application should look like for the user in the end. So we got to develop user stories. We have to design the interface. What is the interface going to look like? What do we want it to look like? What colors? All these other things that are important. And then, of course, how are we going to make calls using APIs? What APIs are we going to use? So API use is an important portion of designing. Development. So in the development phase, they're going to be coding using definition and design parameters. All of those things that we just defined and made as parameters, we're going to use those to actually develop the application. And then some testing can occur in this, but there's a testing phase for this. There can be small tests of small bits of code in this area. Make sure your for loops don't go crazy, stuff like that. Testing. So in the testing phase, this is where we're most concerned with as far as security. This will be pen testing. Hopefully the budget is allowed for pen testing. That will really get a lot of the security issues out. They'll fuzz the application and they'll attempt everything to exploit the application and provide a report. Of course, vulnerability scanning. During the pen test, they'll do vulnerability scanning, but the application developers can conduct vulnerability scanning themselves easily with things like Acunetics or Nessus or other different open source or proprietary vulnerability scanning tools. Dynamic application testing. So DAST, that will be dynamic testing. We'll go over that shortly. And then static testing, SAST, we'll go over that shortly as well. Functional testing. Does the application perform as intended? Does it function well? This will be a quality assurance type thing. And then security testing. Are security controls effective? I don't know. You tell me. We'll do security testing. All right, so next is configuration management for the SDLC. So configuration management is ensuring that new versions, new configurations are implemented properly. So we're going to want to make sure we use version control and implement that properly through policy, changing versions securely and in an organized manner. We're going to want to make sure during this process that documentation is occurring all the time. All changes to the code, the application, versioning needs to be documented properly. Project oversight needs to be conducted and also documented. Any project oversight needs to be conducted for configuration management. And then software entered into organization inventory needs to be documented as well and part of the configuration management policy. So some important standards for secure application development. One we need to remember is ISO IEC 27034-1. These are amazing. We'll get into this in the legal portion. There's going to be about 10 or 15 of these ISOs that we'll have to kind of remember. And it's really difficult because they name them in seemingly random numbers. So the one for this one, for application development, is ISO IEC 27034-1. This one is slightly different than the others, though. So just remember the 34-1 at the end and think of application development. I've said it 3 times, so hopefully that's how I do it. Hopefully it works for you. So we need to go over some important concepts here. ONF, that is the Organization Normative Framework, the Organizational Normative Framework. And this is the framework for all components of application security controls and best practices cataloged and leveraged by the organization. On the other hand, there are application normative frameworks. These are the subsets of the ONF for each specific application. The ANF shares the applicable parts of the ONF needed to achieve an application's required level of security. Something to remember here is that the ANF to ONF relationship is a one-to-one relationship. Every application has an ANF that maps back to the ONF. However, the ONF to ANF relationship is one-to-many. The ONF is overarching and has many ANFs, but the ANF only has one ONF. So, one more time, the ONF is overarching and is only one, the Organizational Normative Framework, and then there are many ANFs under that ONF. So those are application normative frameworks. Let's go to Identity Access Management. So Identity Access Management is normally referred to as IAM. It's used to create, manage, and destroy identities. They're used to verify or authenticate, grant access to systems, or grant access to resources. As far as IAM functionality goes, it's mostly involved with identity management. This would be provisioning identities using unique user ID and passwords, retaining records of all the access and new passwords, new IDs, and then password management, generating and storing and ensuring security controls of the passwords. Other features of IAM would be federated identity management, federation standards, federated identity providers, SSO, and MFA. MFA is multi-factor authentication, SSO single sign-on. We're going to go over those here very shortly. First, let's go over identity repositories. These are directory services for the administration of user accounts and their associated attributes. They customize user roles identities, and access. The directory services used with identity repositories would be X.500 and LDAP, Microsoft Active Directory, Novell eDirectory, or metadata replication and synchronization. As far as single sign-on, this is normally referred to as SSO. You only sign on once to gain access to many resources. This solves the problem of if there are many resources your corporation uses, the user doesn't have to sign in a billion times to use several interfaces at the same time. It is very streamlined, and on the other hand, it is difficult to implement and maintain securely. Attackers can gain access to multiple systems and services with one breached credential. Next, we're going to talk about federated identity management. Federated identity management, or federation in general, is much the same as normal identity management, except it is used to manage identities across disparate organizations. You can think of it as a single sign-on for multiple organizations. It manages identities across organizations. Utilize the web of trust model, which would be to review and approve each other member. This is a very cumbersome process, but is pretty secure. And then you can use a third-party identifier, which is outsourcing review and approval to a third party, as opposed to just doing it yourself. So let's go over the concept of federation. So the federation requires an identity provider who provisions, authenticates, and authenticates identity assertions. And then there are relying parties, the member of the federation that shares resources. In the trusted third-party model of federation, the identity provider is the trusted third party, and the relying parties are each member organization within the federation. There are a bunch of different federation standards, but the most widely used one is SAML 2.0, which stands for Security Assertion Markup Language 2.0. This is an XML-based language. Users outside the organization can be verified and validated without creating identities in multiple locations. They can all go through the single SAML framework. WS Federation breaks up into realms, which explain capabilities of organizations to allow organizations to trust each other and their identity information across other organizations. As far as OAuth is often used in authorization with mobile apps. The OAuth framework provides third-party applications limited access to HTTP services. OpenID Connect, it is an interoperable authentication protocol based on OAuth 2. It allows developers to authenticate users across websites and apps. Multi-factor authentication is comprised of 3 different things. So that would be something you know, like a passphrase or a PIN, something you are, biometrics, something you have, a token, a common access card, or an ID. So by implementing 2 or 3 of these things, you have multi-factor authentication. If you just have one, or you have several of one set of this, say you have a passphrase and a PIN, that's not multi-factor authentication. However, if you have a passphrase and a biometric identifier, you now have multi-factor authentication. If you have all 3, a passphrase, biometric identifier, and a token, then it's much stronger. So let's go ahead towards supplemental security. First is, of course, firewalls. Firewalls are designed as the access point for traffic entering or leaving the perimeter of a network. They come in a variety of designs and capabilities. However, we're going to be mostly concerned with stateful inspection. Stateful inspection allows firewalls to prevent inbound traffic from entering unless the connection had been initiated from inside the network. Stateless inspection creates rules that are followed strictly, but they aren't as aware as stateful inspection. Nowadays, there are application-aware firewalls, which are far superior to these, but they are also very new. However, attackers and attacks are constantly evolving, which led to the Layer 7 WAF, Web Application Firewall. They're deployed in addition to a network firewall and are designed to protect specific web-based applications. Actually, PCI DSS requires them to protect credit card data egress. Of course, the next thing is DAMs, which are database activity monitoring. These monitor for unusual requests. They watch databases specifically for that, and they can alert or take action. They can be agent-based or network-based. And this just means that the agent resides on the machine or an instance of the database, or a network component monitors traffic to and from the database. Of course, API gateways are an important part of layered defense. They can be used to impose such controls on API activities, such as acting as an API proxy, ensuring API access control, limiting connections, logging API use, gathering API metrics, and API security filtering. XML gateways work similarly to API gateways, except they're more concerned with XML and how sensitive data and services are exposed to APIs. They can be software-based or hardware-based and can implement some types of data loss protection. And that's it for XML gateways. So, cloud application architecture. Application Programming Interface, APIs, are the coding components that allow applications to speak to one another, generally through a web interface or some kind, and preferably in a safe and secure manner. That's from Ben Malislow, who wrote the book. So let's go over different types of APIs. So the first type of API is a RESTful API. It is a REST API. And it stands for Representational State Transfer. These are designed to scale capabilities of web-based applications. There's low processing overhead. They use simple URLs, URIs. They're not reliant on one programming language. They're highly scalable, and they output in multiple formats, CSV, JSON, etc. They're efficient and use smaller messages. A SOAP API, which is the Simple Object Access Protocol, are for the exchange of structured information. They're standards-based, reliant on XML specifically. They're intolerant of errors, much slower, and have built-in error handling. So when should we use a RESTful API? Well, we should use it when bandwidth is limited, when stateless operations are used, and when caching is needed. However, when you need to use a SOAP API is when you need asynchronous processing, and when you need format contracts or stateful operations. Tenancy separations. So for this, we're going to be going over multi-tenancy. We're also going to be going over configuring to ensure logical isolation of tenants and prevent the data leakage and corruption of data. Of course, multi-tenancy refers to the concept that there are multiple cloud customers sharing the same host devices and underlying resources. This is an important thing to learn for the CCSP and to remember. It is very important to ensure that the logical isolation of various tenants occurs, as we said, and we don't want data corruption or leakage to occur through that process. As far as cryptography, we're not going to discuss it a lot in this chapter. There's a lot more to discuss in other chapters, but we'll talk about encryption of data at rest. So data at rest, whether it is short-term or long-term storage, would be data that is not moving. Just as we encrypt data at rest in a data center with full disk encryption, things like that, we should also encrypt data at rest within the cloud environment. Something to consider with the cloud environment is that law enforcement may seize a particular piece of hardware which contains many tenants' data on it. This means that even though we can trust them to just look for the data of the singular tenant that they are looking for, they may still have access to some of our data as well. If each tenant applies its own cryptography, however, those tenants under investigation should remain protected from unauthorized disclosure in this type of situation. As far as encryption of data in transit, it's necessary to mitigate against intermediaries, man-in-the-middle attacks, on-path attacks. There are a number of different encryption technologies. As far as the encryption technologies that we need to know about, that would be TLS. It's a protocol that's designed to ensure privacy when communicating between applications. This can occur between two servers or between a client and a server. SSL is the older version that's deprecated of TLS. You might hear the term SSL for TLS being used, but however, TLS is the modern standard. Then there's whole instance encryption, which is also known as whole disk encryption. This is encrypting all of a system's data at rest in one instance. Rather than designating folders being used for encrypted material, the entire storage medium is encrypted. Volume encryption, just like whole disk encryption, volume encryption ensures that you encrypt one partition instead of the whole disk. So if you want to encrypt just one encryption, one volume, or encrypt one volume of a disk, you can do that. So once again, data in transit encryption, that's going to be transport layer security, which ensures privacy when communicating between applications. And then SSL is deprecated in 2015 and replaced with TLS. Data at rest encryption, Whole disk encryption, the entire storage medium is encrypted. Volume encryption, you're encrypting by partition. Then a good note to ensure or to think about is ensure that either way that keys are stored and managed properly, whether you use partition or whole instance encryption. Sandboxing. Sandbox is an important concept, especially in the SDLC. The sandbox is a test environment of isolated devices and cabling, completely separated from the production environment. It can be actual physical space between those. This is to ensure that the sandbox, if compromised, doesn't destroy your actual production environment or access sensitive data. You can use either the SDLC for testing and forensics. A physical sandbox is a test environment of isolated devices and cabling, air-gapped, yep, of course. And then a logical sandbox would be isolated memory space for untrusted and untested code so that they can be run in an isolated instance. Application virtualization, it's somewhat like sandboxing. You can run full application in a protected space. Examples of this would be Linux Wine. Cloud application assurance and validation, you would need to use threat modeling, such as Trike, ASNZS 4360, a very catchy name, CVSS, or the Stride model, and we'll go over some of those shortly. So the Stride model is useful in identifying vulnerabilities in the software development lifecycle. To use the Stride model, we would start with spoofing. Definition of that is to pretend to be someone else. A property of it is authentication. An example would be hacking a victim's email and used to send messages in the name of the victim. Tampering would be changing data or code. This is a problem of integrity. An example would be software executive file is tampered with by hackers. Repudiation, claiming not to do a particular action. Property that's breached is non-repudiation. I have not sent an email to Alice. Of course, who's going to prove it if you don't have non-repudiation? Information disclosure, leakage of sensitive information. This breaches confidentiality. Credit card information available on the internet is an example. Denial of service, non-availability of service. This breaches the confidentiality or the availability principle. An example would be a web application not responding to user requests. And then elevation of privilege, which would be able to perform unauthorized action. Property breached is authorization. And an example would be normal user able to delete admin accounts. So let's go over those once again. Stride model, STRIDE. It is spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. Threat modeling. So we have injection, like SQL injection, LDAP injection, OS injection. These are all forms of injection. There's command injection. There's a whole slew of injection threats. Broken authentication. This breaking a session and stealing items like tokens, passwords, or keys. Cross-site scripting, often abbreviated by XSS. Application allows untrusted data to be sent to a web browser without proper validation or escaping. IDOR, insecure direct object access, reference to internal objects without access control checks. And then security misconfigurations, of course, human error. If a server is misconfigured, the attacker can do a vulnerability scan, see the misconfiguration, and use a known exploit. More threat modeling. You have sensitive data exposure, disclosure of such information as PII, PHI, credit cards, missing function access or level access control, verify function level access privileges before granting access to the UI. Cross-site request forgery, CSRF, logging on to the user's browser manipulated, I spelled it wrong, I know, to send forged requests. Using components with known vulnerabilities. Programming libraries are bad about this because lots of developers use the same code. It's able to be viewed by a lot of people, and then there are a lot of vulnerabilities existing within the code and several different applications because that code is copied and used somewhere else. Invalidated redirects and forwards. Validate redirects and forwards to avoid phishing and farming sites. QoS, quality of service. This is a method of performance versus security. An example of a QoS consideration would be encryption. Enabling encryption in databases will cause a slowdown in performance due to the processing power required for encryption and decryption to occur. And it can also limit the ability to query the database because encrypted data can't be cataloged or interrogated the same way plain text can. Another example is running a HID system on a server. This can slow down the processing time. However, of course, these are more secure, but you trade off for performance. This will always be the case. Software security. So the first thing to think about is penetration testing. This is where you will have a third party find vulnerabilities and exploit them. This is done actively by that third party, and you will receive a report. The second is vulnerability scanning. This is a more passive manner. It searches for known flaws. It's automated and doesn't identify configuration errors, unfortunately. Also, it only searches for known flaws, not 0 days. Sometimes penetration testing, if done really well, can identify some 0-day flaws or vulnerabilities within your application or other network. So let's talk about white box testing. SAST, static application security testing, entails reviewing the source code. It requires a testing team with two kinds of skills and knowledge: how to read the code the program was written with, and the understanding of security. Of course, there's also black box testing. This is usually done with dynamic application security testing, and it entails testing the program as it functions in runtime. The testing team uses inputs and results from the application itself as it's running. While both of these methodologies are completely different, they can be used in conjunction to make sure the applications are secure from both sides of the perspective. We can see here in this diagram from the book how both of them can be used to prevent several different forms of vulnerabilities. Approved APIs. APIs are an often overlooked but serious threat in the cloud. Approving the APIs and keeping them secure requires constant testing and review of the APIs. Some software supply chain management, when it comes to APIs, would be too many third-party APIs. This can be a concern because then we can't properly audit the APIs and ensure that they are being implemented securely. Of course, we need to make sure we audit the APIs to ensure that they are being used securely, and we can find out what we could be lacking in certain APIs. Another thing is strong contracts with the API vendors. We need to ensure that API vendors have a strong contract with the cloud customer. And then lastly, as I said before, security reviews of each API need to be conducted in order to ensure they're still operating securely. As far as open source software, so open source software is a cheaper version of software usually. The benefits are that you can review and test the code itself or yourself, and they're easily modified due to the code being open source. The benefits of proprietary software are that there's less liability for the customer. Usually, proprietary software also keeps its software secret, but this also leads to that lack of liability for the customer because the proprietor could be held liable for certain things. As far as agile development, an important concept now because it's being adopted quite a bit. Agile development speeds up the development of software. It's a framework that was designed to do this. They use a lot of open source code libraries, focus on timely delivery, but definitely not security focused. It's difficult for security professionals to keep up in an agile development model, but it is possible. So securing the network environment. First and foremost, utilizing a VPN, which is an encrypted tunnel that encapsulates communications into as it says, a tunnel, not easily accessed from the outside. A protocol embedded inside another protocol is what you could describe it as. And it protects against intermediaries and communication observation. A VLAN is a logical isolation of portions or segments of the network. Members of a VLAN can only communicate with other members of the same VLAN unless traffic passes through a portal or gateway that leads outside of the VLAN. DHCP involves static addressing, where IP addresses are assigned permanently to a device, or dynamic addressing, which selects IPs from allowed ranges and keeps a record of devices and addresses. It's more secure to use dynamic addressing. DNS stands for the Domain Name Service. It is hierarchical with distributed tables. associates IPs to domain names, so you don't have to type IPs in to get to a website. You can just use a domain name, and it will associate it to the IP, bring you to that website. DNSSEC is a security extension that enhances DNS security. So regular DNS was made a long time ago, and it is not as secure. So DNSSEC is the way to get around that and make it more secure. DNSSEC is concerned with origin authority, DDoS protection, integrity of the data, and reduction of susceptibility to spoofing. So what's next? I know that was a long chapter. I recorded 2 in a row, so I'm sorry if I sound a little, but anyway, so what's next is we got to go to the practice questions. I'll link those in the description. Definitely read the book, and then you can watch chapter 8 as well. So I'm going to continue on. I'll probably take a break before I do another one because I'm starting to sound floofy, and doing these in a row is kind of difficult. So I'll definitely take a break before the next one. But hey, thanks so much for watching. I hope this really helps you to study. Definitely read the book. Definitely comment if you got something to add, something to correct, especially on this one. Like I said, I was not as well prepared, but that's okay. So you have a wonderful day, and thanks so much for watching. Bye.